Good morning, good afternoon, or good evening. This is going to be a full paper work through of the June 2018 4HR. Before we start, the warning as always, you shouldn't be using this video if you haven't already attempted the paper yourself. All the value from these questions come from struggling with them before you go looking for hints. I'm going to work through this paper in its entirety, trying to give the hints as I go on my thought process about each of these questions, and ideally producing a perfect set of solutions. If you do spot any errors, please do let me know. Otherwise, let's get started. Before starting any paper, glancing at the front page, reminding yourself of what's allowed and what's not. We have our formula page on page 2. I have my calculator ready just off to the side, and I've got all the other equipment that I need. Remind ourselves on the formula sheet, making sure that we come back to refer to this to double check any of the formulas that we end up needing to use. So going straight in, question 1. Quite a common question 1 actually. A bit of kind of a reverse mean median mode problem solving. We have 3 numbers. They have a mean of 17, a median of 20, and a range of 27. Well, if they've got a median of 20, the middle number has to be 20, having only 3 numbers. I'm going to give the other 2 names, X and Y. The range of 27 is saying the difference between those is 27. Y is the larger one, so Y minus X is 27. From the fact that the mean is 17, we have that the total of all the 3 numbers is 3 lots of 17 has to be 51. Losing the 30, we have the sum, losing the 20, we have that the sum of the remaining 2 is 31, and that's a very simple set of simultaneous equations. You can try and do this with just logic. I like to do this with simultaneous equations to be really clear. If I add them, the x's cancel, and I get that 2y is 58, or y is 29, which using the first of our 2 equations, the difference is 27. So x has to be 2. We wanted to find the 3 numbers. Let's put them on the answer line. Double checking before I go. If I do add those up and divide by 3, I do get 17. Middle number is 20 and the range is 27. Question 2. Now, although it doesn't have it drawn in the picture, we've been told in the question that this is a parallelogram. So we've got a couple of parallel sides. So I'm reminding myself as I'm starting to read the question that the F angles, the corresponding, are equal. The Z angles, the alternate, are equal. And the C shape, the co-interior, add up to 180. Write down the size of angle Z. And angle Z I can see creates this Z shape as previously mentioned, with the 67. Now unfortunately I can't write because Z shape. I need to use the official phrasing, and that's alternate angles are equal. They're on alternate sides of that crossing line. Work out the size of angle Y. We haven't been told anything yet about B to F. So although it might look like BFC is isosceles, if we haven't been told it, we can't assume it. I can work out the angle on the other side of F. Angles on a straight line add up to 180, so I know that angle there is 60. I also have a F shape here using that 67 again. So I know the angle down here is 67. So the angle Y is the angles in a triangle add up to 180. Take away the other 2, giving me an answer of 53. Didn't ask me to give my reasons. You can if you wish, but not necessary. Question 3. Table gives information about trees in 20 gardens. I'm going to keep track of that 20. Work out the total number of trees. It's a bit odd here, because normally it would ask you to calculate the mean. So this is actually asking you to work out halfway towards the mean. Total number of trees is the total of the fx column. Those two gardens each have no trees, so there's 0 trees in those gardens. Those gardens each have 1 tree each, one lot of 7. Those 3 gardens have 2 trees, there's 6 trees in those gardens, etc. 12, 12 and 5, and I'm asking for the total of that column. So trusty calculator tells me that there are 42 trees in total. Now if it did want the mean, I would then have to divide that by the 20 gardens, but it didn't, just wanted the total. The median number of trees in these gardens, well, the median is halfway up, and you may remember the formula n plus 1 over 2 to find where the medianth tree is. That's 21 over 2, so we're looking for the 10.5th tree. Well, up until, well, the number of gardens with 0 and 1 trees, there are 9 with 0 and 1 tree. The next 3 all have 2 trees, so that's a 10th, 11th and 12th garden, all have 2 trees. Well, the 10.5th garden is then definitely going to have 2 trees. Charlotte earns £8.50 per hour. Pay rise of 6%. It's a percentage increase question. Well, a pay rise of 6% is going to need 106%, or as a multiplier 1.06. So in my calculator I'm going to do my multiplier multiplied by the original amount, and that gives me a new hourly rate of £9.01. Didn't need to do any rounding there, that actually came out exactly. Question 5 are transformations. On the grid, we're going to enlarge P with scale factor 3 and center A. Well, the center means we have to always start counting from there. So I'm going to go up to this top left corner first. I went 1 up and 2 across. Scale factor 3 means I need to go 3 up and 6 across. So my new top left corner ends up being there. Now the really sneaky thing is, now I've got where the shape is going to land, I can just enlarge it in the normal way. The downwards part was length 1, so now it has to be length 3. We've got 1 diagonally, so now I'm going to have 3 diagonally back up, 3 tall, and it was 2 wide, so it's now 6 wide, and that's my new shape. Sometimes it does ask you to label your new shape, this one did not. Second question, fully describe the transformation which maps R onto T. Now they haven't changed size, so it's not an enlargement. It's not a translation because they're now in a different orientation. We can imagine trying to reflect this shape, but again that does not work, so it has to be a rotation. You'll notice there are 3 marks available, so we need to say 3 things. So it's a rotation, there's 1 by 90 degrees clockwise. We're going from R onto T, so we are going round that way. And finally we need to find the center. Now center you kind of have to do by eye. Most of the time it's a nice position. And here you can check with tracing paper, but the center is 0, 0. Question 6. A plane is travelling from Sydney to Wellington. We have the distance and the average speed. We want to find the time. So you've got speed equals distance over time. Using the triangle, if we cover up time, that says that t is d over s. 2,240 over 805. Now it's worth checking at that point, do the units match up? And yes, indeed, they do. These are in kilometers and kilometers per hour. Doing the division, you get 2.78 and a load of decimals. Now that is in hours. We need to convert this into hours and minutes. We know the hours part, there are 2 whole hours. To find the minutes part, we need the decimal bit, multiply that by 60. Best way in your calculator is to do the answer, take away 2, to just get the fractional part, and multiply that by 60. And that is still a horrible fraction, a horrible decimal, as 46.95, and that goes on a lot as well. We want it to the nearest minute, so that's just 47. Now for those who want to be really sneaky, there is a button on the calculator which does this for us. If we go to this stage and use the button, which is a little circle and then some apostrophes, I'm not great at drawing that, so small. If we hit that button, it automatically converts that fraction, that decimal, into hours, minutes, and even seconds as well. And there you can see that 2 hours, 46 minutes, and 57 seconds does indeed round to the 247 that we had. Simultaneous equations. Quite early in the paper, but then these are quite simple ones. The first one is already y equals. So I'm going to sub the first into the second. Again, I really like telling the examiner very clearly what my intent is at every position. So now it's 7x minus 4x instead of minus y. It's negative 13.5. So 3x. Simplifying the left-hand side. So x is negative 4.5. Now I've got x, I can sub back into either, well actually the first one is so easy that y is just 4 lots of this now. 4 lots of 4.5, or negative 4.5 is negative 18. Nice thing about simultaneous equations is if you sub both of those back in to both equations and it works in both, then you have to have got the right answer. So I've already kind of subbed into the first one with my working and doing a quick check into the second. It does satisfy the second equation, so it has to be the right answer. Question 8. Straight away it looks like a bearings question, just as they've given us a picture already. And yes, indeed, we are trying to work out the bearing. City C is east of A and north of B, and we've got a couple of distances. We want the bearing of city B from city A. From means that's where I care about the angle. So it's that entire angle there which I actually care about. Now I can't find that angle directly, so instead I'm going to try and find this little angle inside the triangle. Use a bit of SOHCAHTOA. Here we have the adjacent and we have the hypotenuse. So that's cos theta is 43 over 70. Cos inversing that gives me theta is cos inverse of 43 over 70. So my angle is 52.09. Again, I like to put the exact answer with the dots at least once for the examiner to see it. Now my bearing, well, I didn't just want that bit, I wanted that bit and the extra 90 degrees. Notice the angle up there is 90 between north and east. You need to add on 90, and you'll recall that bearings have to be given to as a 3-figure bearing, so it's the nearest degree, and even the question does remind us of that fact. Question 9, we get to our core algebra skills. We've got some simplifications to do. Remembering our laws of indices, power of a power, we multiply powers. Here let's do each section separately. So we have to cube the 3, we multiply the powers on the A, we multiply the powers on the B. So our answer 3 cubed is 27, A to the 6, B to the 12. Expand and simplify. We're lucky there's a plus in the middle, that makes our life slightly easier. Doing 4 times everything inside. So we get 4g minus 8h. We're then doing 5 times everything inside. 10g minus 15h. Now we can collect like terms. G's come together, h's come together. Just making sure that we're careful with the minuses on all the h's. Expand and simplify. Double brackets, we're thinking FOIL. Firsts, outsides, insides, lasts. Combining the middle terms together as so. Solve the inequalities. This is what I would call a sandwich inequality. Now, in the same way with equations, whatever we do to one part we have to do to the other. With inequalities, whatever we do to one part we do to every part. So I can take away 3 from everything, leaving just 2p in the middle, and then I divide every section by 2 to get the answer as so. Now you could split the inequality into 2 separate ones. Ignore the less than 13, just solve the left part. Similarly, ignore the minus 5, solve the right part. But you can do it all together, providing the middle section isn't horrible, which this one was not. Question 10. Write 280 as a product of prime factors. You can either use the chimney or the factor tree. I'm quite keen on the factor tree. 28 I recognise as 7 times 4, so 280 is 7 times 40, 7's a prime, 45 times 8, and then finally 8 just splits into a bunch of 2's. Doesn't matter which order you combine them, but answer now does have to be written as a product. And notice I've combined all my 2's together to write them as 2 cubed. Now we're going to try and find the highest common factor of 630 and 280. Well, I'm going to do the 630 factor tree nice and quick. So again, I notice it's 7 times, well, 9 to make 63. So 7 times 90. Well, 90 is 9 times 10. That's quite a nice setup. And then I get all the prime factors of each of those. So 630 I can write as 2 times 3 squared times 5 times 7. If I'm looking for the highest common factor between these two, I'm now looking at their prime factorizations and looking for everything that's in common. So in common to both of those lists, well, there's a single 2 in common, there's a single 5 and a single 7. So I pick out those common factors, get to 5 and 7, multiply those together, and 70 is my highest common factor. And it's quite easy to check that yes, 70 goes into 280 and into 630. Question 11. We have some businessmen given the number of different countries they had visited. We want to work out the interquartile range. Well, 15 is quite nice for working out interquartile range. It's always nice when it's one less than a multiple of 4. These numbers are already in order. So the lower quartile is at 15 plus 1 over 4. So that's the fourth value. The fourth value is that 3 there. That's our lower quartile. The upper quartile is at 3 lots of that, is at the 12th. So that's our 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th. Is that one there? Equivalently, I could have counted 4 down from the top, and that would be symmetrically equivalent. So the interquartile range, the IQR, is the difference between them is 7. An algebraic fraction now. Fortunately for us, the algebra is only in the numerator. Now that does make the working quite a bit easier. Best technique for algebraic fractions is to get rid of the fractions first. So I want to get rid of the over 3 and the over 4. Well, to get rid of both of those at the same time, I can multiply throughout by 12. Multiplying the first term by 12, the 3 cancels, and I'm left with 4 lots of the numerator. The opposite, over 4, the 4 cancels, leaving behind a 3, and then not forgetting the 2 on the other side does get involved in the party and becomes a 24. Now this is a much simpler question. It's expanding brackets. Then we're going to simplify, collect our like terms together. So that's 5x plus 1 is 24. It's a little sad that that's a plus, not a minus. If it was a minus 1, the number would have been, our answer would have been quite pleasant. Unfortunately, it appears the answer is 23 over 5, or 4.6 if you really want to turn it into a decimal. Now to check that I'm correct, because I kind of wanted my answer to be a lot nicer, I can type into my calculator the left hand side with that 4.6 in there to check whether it does indeed give 2 or I have made an actual mistake. And typing all that in, indeed my calculator does tell me the answer came out as 2. So again, I know that answer is correct. Question 13 is standard form. Standard form, we pick a number between 1 and 10 to represent the number. Here 3.7. Then our power is how far the decimal place has had to move. And it's moves 1, 2, 3, 4, 5 places times 10 to the 5, but it's a small number, so it should be 10 to the minus 5. We want to write this next number in standard form, and you'll notice the number in front is not between 1 and 10. So you can rewrite this as a proper number, putting a load of zeros on the end. I prefer to make an adjustment. So we actually wanted 2.34, so we've had to move the decimal place an extra 2 places. And because we've made the number in front smaller, we need to make the power bigger. A wordy one to finish off. The population of China is, the population of Morocco is. The population of China is K times the population of Morocco. So that is what we've been told. The 1.4 times 10 to the 9 is K lots of the 3.5 times 10 to the 7. Doing a division to isolate K. Again, typing that into my calculator. You can use, and you should use, the times 10 to the power button, which makes it a lot quicker to type these kind of things in. Typing that in gives you an answer nicely as 40, which does seem reasonable. The powers were different by 2, so something in the 10 to 100 region would make a lot of sense. Question 14. At this point we're probably reaching around the staples. We're starting to get to the more challenging questions. We have a bag of marbles, 2 bags, bag A and bag B. Bag A has 3 red, 4 green. Already I can see down on my tree diagram, I can see the 3 out of 7 for red, 4 out of 7 is then needed for green. In bag B, there are 4 red and 5 yellow, so that's 4 out of 9, 5 out of 9. Now really I should have finished reading the question first to check there wasn't anything sneaky going on about moving marbles between bags. But actually no, there isn't. We're just taking 1 from each. We want the probability we take 2 marbles. So we're looking for, 2 red marbles, we want red, then red. As we move through our picture, we're saying red and red. We say and in probability, we're multiplying. 3/7 times 4/9 gives us an answer simplified as 4/21. Our graph plotting question, be table of values. Table of values is just sub the value in to get the y. So I'm going to sub -3 into that calculation to find the value of y. So it's -3 cubed, subtract 2 lots of -3, add another 3, so that's -18. Do the same for 1. 1's quite a nice one. That's much easier to type in. And then finally subbing in 3, 24 over there. Now we want to draw the graph for those values. Now we need to plot these accurately. You're going to have a much better job, of course, with pencil with the real paper. So -3, 18. It's up there, I missed a little bit. -2, -1, -1, 4, 0, 3, 1, 2, 2, 7, and 3, 24. Now it's nice that these coordinates were just going up by 1 each time. And already I've just noticed my problem. So this -3, -18, I drew a positive 18, so it should be down here instead. And the reason I spotted that, because I know that a cubic graph normally has that style of shape, whereas mine seemed to be getting that kind, which is not a cubic. Now we've got our points, we should connect them together with a nice smooth line and pencil again in real. On the real paper you'll be able to draw that a lot more accurately. I did miss my -2 coordinate a tad. By drawing a suitable line on the graph, find estimates for that equation. Well, that's nothing. Well, it's similar, but it's not quite the one I've drawn. This is a sneaky trick, but if we subtract what we have, which was -2x plus 3, and we subtract the equation that we want to solve, it tells us what line to draw to find the perfect point of intersection. So if I subtract these, was y take away 0, just the y, the x cubes cancel, 3x plus 2. So if I draw the line 3x plus 2 onto my grid, I can find my points of intersection quite easily. Now it does say find estimates for the solutions, so I'm expecting to have quite a few. So 3x plus 2, it crosses the y-axis at 2. When x is 1, that means it's 5, just by subbing it in. And at -1, it's at -1. Now we only really need 2 points. Because I don't have pencil ruler on the iPad, I'm going to have a couple more to try and line them up a little more pleasantly. So there's my line. I now want the solutions in X, so I'm looking for the coordinates where it cuts. So there, that's negative, so it's positive, sorry, 0.15. It was halfway between the two. We've got one there, which I'm going to put as 2.05. And then we've got a negative solution as well, which appears to be symmetric as well, negative 2.05. Now you do get quite a bit of leniency for these estimation style questions. If you drew your graph slightly differently, well, certainly you can see my graph now down there, -2, doesn't really look right. So my negative 2.05 is probably quite inaccurate, whereas the other two seem a lot better. Question 16, and make W the subject into quite an unpleasant looking square root of a fraction. Let's first get rid of that square root. So we're going to square both sides. So p squared, squaring the fraction just removes the square root. I don't like fractions if I can help it, so I'm going to get rid of the fractiony bit, multiplying up by the denominator. I now have brackets. If I can help it, I'll get rid of brackets. And now I've made arguably the nicest expanded version of the equation. I want W to be the subject, so I'm going to put all the W terms on the left and put all the other things on the right. Factorizing the W means that there's now only one W in the whole equation, so I can isolate it by dividing by the bracket. Now notice there is a p squared on the top and on the denominator. They are not common to everything. There is no p's in the 4 or in the -1, so I cannot cancel those p squareds at all. There is nothing more I can do to that equation. I've made W the subject. Intersecting chords. And this one has the formula, and it's actually a relatively simple formula, but if you don't remember it, these questions are impossible. The formula states that if you multiply two parts of the chord, so that's AP and PC, that's the same as if you multiply the equivalent two parts on a different chord, so that's BP and PD. Putting in everything we know, we're trying to find the length of AP, or as you see the question just over there says PA, does not matter the order you write those. Putting in the other values, 4.4 equals 2.5 times 5.5. So AP in my calculator is going to be that product divided by 4.4. Typing that in, we get the length of AP is 3. That's incredibly promising that we got such a nice value out. The question didn't tell us to round, so if I got a horrible decimal I would have been very worried. Question 18, we have histograms. A very classic histogram question, 2 parts, 2 marks each. Complete the table, complete the histogram. I'm not going to separate the 2 parts of the question, I'm just going to do them all together. First thing to try and find is something you know everything about. I'll add my frequency density in up there. I know everything about the 50 to 80 bar. So that bar there, I know the frequency and I have the bar. Everything else I only have one or the other. So the base of that is 30. The frequency is 15. Remember that frequency density is frequency divided by the class width. So there the frequency density is 30 divided by 15 is 2. So the height of that bar there is 2. I'm going to spend a bit of time to make sure that I understand the scale. There are large 10 boxes, but the 2 doesn't go through a large 10 box. So I'm going to look at the 5 by 5s. There's 1, 2, 3, 4, 5 5 by 5s to get up to 2. So each of those, if I do 2 divided by 5, each of the 5 by 5 boxes is 0.4, 0.8, 1.2, 1.6. And I'm going to go all the way up to the top, 2.8, 3.2. Well, I could also, if I divide that by 5 again, each tiny little box is 0.08. So tiny little boxes are 0.08. That might be helpful if I don't go through a perfect place, although all the bars I can see do. We can now read off the frequency densities for some others. The frequency density for 80 to 120 is 2.8. Well, frequency, I like to say frequency equals area. That's also the same as frequency density times class width. So there we've got a height, or a frequency density of 2.8, and a width of 40, which gives me my frequency. Now I'm just a little concerned, and I think I've actually done some things upside down. I have frequency density is frequency over class width, which is not 30 divided by 2, sorry, not 30 divided by 15, but 15 divided by 30, which is 0.5. So I've actually got that scale wrong. Reason I spotted there, and I would say it's planned, but it wasn't, was my calculator was telling me that this frequency was 112, which is completely nonsense looking at the rest of my setup. So whenever you do notice something's a bit odd, you can go back, check and reflect. Did you do something else wrong, or is it supposed to be that weird? So actually this height here should be 0.5, and that actually makes it a lot nicer. That's 5 boxes for 0.5, means that each of these boxes is 0.1. We got up to 0.8. Being able to spot your own mistakes before they become too serious is a really powerful skill. So now again, 80 to 120 has a height of 0.7, and now 0.7 times 40 is a frequency of 28, which is much more reasonable for where the rest of our data lies. Our other bar, 120 to 180, that has a height of 0.3, so our frequency is 0.3 times 60, and that has a frequency of 18, which again seems much more in line with what the rest of the working wanted. We've completed the table. We now need to try and complete the graph. So here we need our further frequency densities. For the top one, we've got a frequency of 10 with a class width of 50. That gives me a frequency density of 0.2. 0 to 50 at a height of 0.2. Add that into my picture. 180 to 240, frequency of 12, a base or a class width of 60 is again a 0.2. So 180 to 240, and you be careful with your scale along the bottom and your height, gives you that bar at 0.2 again. Finally, we've got a frequency of 8 divided by a width of 80 this time, and a height of 0.1. 240 to 320 has a height of 0.1, as so. So we completed our table in purple, completed our graph in red. Question 19. We have a rectangular piece of card and we've cut a hole out of the center, and we care about the area of which remains. Well, we can find that area by doing the area of the whole rectangle, base times height, and subtracting the cutout. That expression is that shaded area, which we've been told is 45. I'm going to do a bit of simplification. We're aiming for a quadratic, so let's FOIL the double bracket, bring everything together on the left. I've got my 7x for my x and 6x, got a plus 3, a minus 6, and I also need to subtract the 45 to get the minus 48 as the question stated. I'm going to just give the examiner a pointer. I did remember to subtract the 45, I haven't just cheated by looking at the show that. We want to find the value of x now. Well, this is a real problem, so we're going to expect x to be a positive number at least. And 3 sig fig implies the numbers are not going to be nice. So quadratic formula is probably our best bet. I'm going to write it out with the numbers subbed in. And this is important because this is often one of the lines in the mark scheme that the examiner is looking for. And just by writing that, without doing any calculations yet, I've got my method mark. Now type it into my calculator. If I do mistype something in any way, I've still got some of the marks. This is quite a horrendous formula to type in. With the positive sign, I get that, and then just using the arrow keys to change to the minus the root gives me negative 6.95, etc. Well, now it goes back to that fact I mentioned before. These side lengths up at the top, these have to be positive, and if x was negative 6.9, those are not positive, so that is not a solution. However, they are positive with the other one, so let's put that on the answer line, rounded to the 3 sig fig that the question asked for. Question 20. Use algebra to show the recurring decimal is as so. Use algebra means we can't cheat in any way. We have to use our x equals trick. So I'm going to let x equal that recurring decimal. I'm going to do away with the dots and just write the recurring part out a few times. The technique is to first isolate, or to bring the recurring part in front of the decimal place. To do that, we need to times by 1,000. That decimal place has to move 3 spots. I then need another version of x so that the decimal places line up once again, and I can do that by moving the decimal place only 1 spot, i.e. by timesing by 10. Then if I subtract 990x on the left and on the right, all of the decimal places cancel completely, and then dividing through 276 over 990, and now I'm hoping that that does simplify to the required answer. I'm going to type it into my calculator. Yes, it does. Just for the sake of the examiner, I'm going to make it clear how, and I'm going to check my calculator what the common factor was. Common factor was 6, so I've divided top and bottom by 6 to simplify. Trying to make it as explicit to the examiner as I can that I did not cheat too much. Finally, or next question, subtracting algebraic fractions. We need a common denominator. For algebraic fractions, the only choice is all of the brackets multiplied together. Now we need the equivalent fractions. For the first, we times top and bottom by x minus 3. So an x minus 3 has to appear in the top. On the second, an x minus 4 appears in the top. Simplifying, we get x squared minus 9. Subtract the second one, which was x squared minus 16. And right now you should be screaming at your screens, I need this second one in a bracket because I'm subtracting the entirety of that double bracket. So it needs to have a minus. Simplifying the top, I've got the x squared minus x squared, so they cancel. I've got minus 9 minus minus 16. So that's minus 9 plus 16. You can, if you want, expand out the denominator, but not required. That is, as a single fraction, in its simplest form. Question 22. A horrendous indices question. Once again, the formatting isn't very nice. I believe that should be a multiply there. So let's try and simplify this as much as possible. Just trying to recall the actual paper, whether it was a multiply or it's intended to be a divide. I'm going to stick with it being a multiply. I'm just a bit worried because it's going to give a horrible power 4. No, it's not. No, it's not. My apologies. This is perfect. So let's simplify each of the fractions first. If we divide, we subtract the powers. And similarly for that one. I'm also going to rewrite the 125. 125 is 5 cubed. Multiplying now, we add the powers. So we've now got 2n squared minus 5n, and then a minus 9 from the other two parts equals 3. Sorry, equals 5 to the power of 3. These are both 5 to the powers, so we can equate the powers and lose the 5s completely. This now is an unpleasant quadratic to try and solve. Now the question didn't say give to 3 sig fig, so I'm going to assume that this factorizes. And if I think particularly hard, 12 I can write as 3 and 4. 2 times 4 makes 8. Combined with a 3 will make a minus 5. And those will be the signs that make it so. Of course, if you prefer split the middle, that is also a perfectly valid technique. So n is negative a third, or sorry, negative 3 over 2, or 4. Looking back to the question did say n is strictly greater than 0. So my answer is n equals 4. Now you can again sub 4 into that original left-hand side. And if you do sub 4 in exactly as it's written, you should get 125 out as your answer, giving you that confirmation that you've done that correctly. Question 23. Here we have a 3D trig style question. I have a pyramid with a horizontal square base. The vertex is above the center. Triangular faces are all the same isosceles. We have in ABP, the AP and PB, the isosceles sides are both 11, the angle is 72. We want to work out the height of this pyramid. So there's a few things that we need to be able to do to start with. We do know that the base is square. To get the height, there are various triangles we can try and use. Now from experience, I think the best is probably going to be going to the center, which I'm going to call M here, of one of the faces. And that way we have a right angle triangle, and that P to M is kind of your perfect, it's called a median of the triangle. So that's going to be my final triangle that I'm going to use. But right now I know nothing about that triangle, so I need two sides. So let's first try and find P to M. Now I'm going to cut that front face in half and use the triangle PMB, because I know PMB, the angle is 72. I know that PB is 11. So that will give me PM using SOHCAHTOA. We've got the angle opposite hypotenuse. So sine 72 is PM over 11. Using labelled names, again, is one of the things that the examiners find incredibly useful in following your working. Typing that into my calculator, 11 sine 72 is 10.46 dot dot dot. I'm going to keep that in my calculator for when I use it again. Well, that was one side in our final PMO triangle. I now need OM, and this is where using the symmetry, the fact that it's a square base, is helpful. M to B is actually going to be exactly the same as O to M. M to B is half of the front side, which is going to be the same as half of the back side, sorry, the left or right side, which is exactly OM. So actually OM is the same as MB. Or we can use the same triangle that we've already got here. We now have the adjacent. So sine 72 is the adjacent, which is MB, over the hypotenuse 11. Sorry, not sine this time. We're now cos for the adjacent. So MB is 11 cos 72, which again in my calculator tells me 11 cos 72 is 3.399, etc. Makes sense that's shorter than the other. It's a taller pyramid rather than being a short stubby one. Well, now OM is the same as MB using the symmetry arguments. So now I must be almost done with the questions. I've almost run out of working space. P at the top, M there, O there, and we are looking for O to P. You know P to M is our 10.46. You know M to O is our 3.399. Now we should be trying to use the exact values if possible, or at least using more accuracy than they want. So 4 sig fig is probably sufficient. This is then a Pythagoras style. So you're going to have those squared. We're looking for a shorter side, so it'll end up being a subtraction. So our 10.46 squared, take away this 3.39 squared, gives me OP squared. I'm writing down some of my working out, enough to show the examiner I know what I'm doing. Square rooting that answer and rounding to 3 sig fig, just in time for the answer line. A difficult question to spot that OM, and to actually spot which triangle is useful for the final step. Question 24. We have a regular pentagon inside of a circle. We want the perimeter of that region. Well, we have to find it in two separate parts. We need to find the straight bit and the curved bit. The trick here is to create one of these pizza slices. It's a pentagon which means that we've cut this pizza into 5 parts. 360 divided by 5 says that angle there is 72. The straight part is then a triangle created with a side angle side set up. So that straight part, let's call it, I'm going to call it A, and I'll call that bit B. So A squared using the cosine rule, 6.8 squared plus 6.8 squared minus 2 lots of times cos angle. And that is on your formula sheet, which you should go check that you've quoted correctly each time you use it. Typing that into my calculator gives me the squared side is 63.9, etc. And then the actual side is 7.9938, etc. Again, I'm putting that value down to more accuracy than my answer actually wants. Question wants the 3 sig fig, so I'm going to use a few more decimal places. I don't need the entire calculator display. For the B, well, that's an arc, and we have our formula for arc length, which is the angle over 360, that's a fraction of the circle, times by the entire circumference. So that's 72 over 360 times 2 pi times 6.8. And the astute among you would notice that 72 over 360 is a fifth. Well, that's exactly how we got the 72 in the first place. It's a fifth of the entire circle. That comes out as 8.5451, etc. Again, a little bit more accuracy than what the final answer wants. The perimeter then is the triangle bit plus the arcy bit. So it's at 8.5 plus the 7.9938, giving me 16.53, etc. Onto the answer line, I'm going to put my answer to the degree of accuracy they wanted to 3 sig fig, 16.5. We're to our final question now. Notice it says at the bottom the total number of marks. We know we've got near to the end. A box in the shape of a cube, correct to 1 dp. A spherical ball, correct to the nearest millimeter. We want an upper bound. It's unusual to get a bound question quite this late in the paper, but because it's all in the context of volumes, it makes it that little bit more difficult. First thing you should always do with bound questions is to write out all of the useful bounds. So we've got 11.5 to the nearest decimal place with its upper and lower bound, 5.1. Nearest millimeter, when written in centimeters, is also to the nearest decimal place. So 505 and 515. We want the upper bound for the volume of the box which is not occupied. So that volume we would normally work out as the cube volume subtract the sphere volume. That will work out what's not occupied. Well, we want the upper bound, so upper bound for that volume, we want the biggest possible cube, but we want to take away the lowest possible sphere. Volume of a cube is just the side length cubed. Upper bound is being used here. Volume of a sphere, 4/3 pi r cubed. We've actually been told in the question what to use pi as. We've been told to use pi as 3.14 rather than the pi button on our calculator. If we're starting to make bounds, then having a exact value is reasonable. Lower bound for the sphere, we're using 5.05 cubed. Again, I've written that out in full. It's quite a difficult thing to type into your calculator accurately. So of course you should type these kind of things in twice to double check. But because I've written it out in full once, if I've got this bit wrong from just typo, then the examiner knows I've actually been on the right lines. Question is asking to give us answer correct to the nearest whole number. That's 1001 units were all in centimeters cubed. Does the answer seem reasonable? Well, the sphere looks like it only just fits in the box. And if I do 11.5 cubed to work out what the box's volume is, well, that's 1,500. So having 1,000 space left over does seem quite high, but then it is an upper bound that we're caring about here. So it doesn't seem completely out of the realms of possibility. That is to the end of the paper. If you did spot any errors or wish to discuss any of these questions further, please do let me know. Otherwise, have a wonderful rest of your day and take care.